Joey, Justin, Gigi, Stephanie, Carol. Micah, Tristan, Lee.
Any questions?
This is kind of a long question.
Go for it.
There's one of the, like, old tests.
Yes.
One of the questions I kinda got stuck. It's on the test one, fall 2016.
Test one, fall 2015. 2016.
And then number two, I got till here,
Hammer throw.
and then I couldn't find the radius. I thought there was enough information. I was even in the tutoring lab, and I asked Michael, and he didn't know either.
Michael. Make sure you harass him every time you see him. All right.
I tried my best.
Yeah, take this up there too. All right, hammer throw attached to a chain. So basically we're gonna be swinging this thing around. 7.26 kilograms, 1.22 meters. Takes place on Mars, which I think is 3.8 meters per second squared.
It says it at the top with all the information, I don't remember.
All right, I might change that. Theta is the angle between the horizontal, so that's theta there. And equations of motion, radius of the circular path. And then okay, so C was the one that messed you up?
Well, see, the answer for it in your answer key was just like the, like, equation, like
Yeah.
cosine WL or whatever it was, which I got that, but then afterwards, you kinda have to know the radius to know the answers to the other questions.
All right, you're gonna have to feed me some of the other questions. All right, so this is just like in the lab, where we've got tension acting this way, an angle theta there, because those angles are congruent. So I know my centrifugal force, got weight acting down there, usually with a W. Centrifugal force is equal to mv squared over r, or m omega squared r. Breaking that up, I know I skipped ahead. I've got tension, sine of theta going up, tension cosine of theta going to the left, weight acting down. My equations of motion would be tension cosine of theta is equal to m omega squared r, where r is this distance here, and that is L. I guess I just made that a capital R over there, so we'll make a capital R here. And I know tension sine theta minus the weight is equal to 0. Those are my equations of motion. It is weakly worded, that part C. I do want R in terms of L and theta. So R is equal to L cosine theta. So it's looking physically at this triangle here. That's supposed to be a right angle. It's the adjacent side, so L cosine theta. What was the part D?
If he whirls the mass around horizontally at a constant speed of 20 meters per second, what is the angular speed?
Okay. Wow. Okay, there's some other wording in there, but that is just incredibly big. I give you theta. D also in terms of letters, or was D an actual number?
This is an actual number, that's why I got confused.
Alright, so that's more difficult than I was expecting. Alright, so what do we know? I know FT cosine theta is equal to mv squared over r, which is equal to m omega squared r. I know r is equal to L cosine theta. So I can plug that into there. So this was one of your analysis questions in this trivial force lab. We end up with F equals m omega squared L. You know the mass. You know L. And I also know that Ft sine theta is equal to mg. You know G, you know M. All right. If I take that equation and divide by that equation, don't have R there. Plug that into there. Masses cancel out. Oh, okay. So Ft cosine theta is equal to m v squared over L cosine theta. I know m, v, L. I don't know theta or tension. So tension is equal to mg over sine theta. Plug that into here. So I have mg cosine theta over sine theta is equal to mv squared over L cosine theta. So at this point, I have only one unknown, theta. Solve. Mass cancels out. I'm left with G cosine squared theta, GL cosine squared theta is equal to V squared sine theta. Yeah, this will work out nicely. And then trig substitution.
Wait, where'd the L come from on that side?
I cross multiplied.
Oh, okay.
It came from here.
Okay.
What's the relationship between cosine squared and sine squared?
Equals tangent. No. One.
What is the relationship?
Pythagorean theorem.
Okay. You're dancing around it, so I'm gonna go ahead and spoil it for those who just are too shy to get shouted out. I know that sine squared theta plus cosine squared theta equals 1. That's the relationship between sine squared and cosine squared.
Okay.
So we have LG 1 minus sine squared theta is equal to V squared sine theta. So distributing LG minus LG sine squared theta equals V squared sine theta. I've got a quadratic here. So I'm gonna solve for sine theta. Sine theta is basically my unknown at the moment. So presented,
Wait, where'd the cosine go?
sine squared plus cosine squared equals 1. So cosine squared is 1 minus sine squared.
Oh, okay.
So I made that substitution. Don't need the stuff at this one. So if I just let x be sine theta, I have LG minus LG x squared is equal to V squared x. I know V, I know G, I know L. X is my unknown. So I've got LG x squared plus V squared x minus LG. Quadratic formula. So we'll end up with x, which is sine theta, is equal to negative V squared plus or minus the square root of V to the 4th minus 4 times LG times negative LG over 2LG. Plug in the numbers that you know. Solve for theta. Plug in the numbers you know, you get 2 answers for sine of theta. One will make sense, one will not. Then solve for theta.
Solving for this, you'll take the arctan of, or the arcsine of that number that
Yeah.
came out.
Of
The more
what's going to be equal to
than-
something, so yeah, you do the arc sine of whatever you get over here.
This was a picture of the.
No, it was an old test.
So I forgot, what part D was, what is the angular
Oh,
velocity?
yeah, what was the angular speed?
Angular speed. All right, so now that I have theta, I can, well, I know that the radius is L sine theta. Try that one again. L cosine theta. I know L, I know theta now. I can find R, and I know V is equal to omega R, so omega is V over R. So V is given, R you just found. All right, 2 things. One, that was a hard problem. 2, trig was required before taking 151 at that point.
Because we just started identities in the
Okay.
lecture class. That's why I was like, oh, it equals Pythagorean theorem.
Yeah, in essence, yes.
Indeed, so.
All right,
That makes sense. Thank you.
yeah. And, if wording it today, so it's 2016. Yeah, I should have known better by then, but I would break it down a little bit more and be more explicit about for which ones am I expecting a numeric answer and which ones I'm expecting a formula.
Yeah.
And it's also possible that I wrote on the board that information on the day of the test back in 2016.
More of a lucky thing. So on this particular problem, now I believe this was partly my fault as well. I circled 2 things. One was circled, one was squared. So this one was missing units, this one was not missing units. I feel like that was doctored for units, right? So,
Yeah, well, I averaged it.
average.
So if you had left that as your answer, it would have been 10 points. If you had left that as your answer, it was 7 points, so I split the difference and gave you 8.5. That's where that comes from.
Okay. So test corrections on that front would be.
Ignore the circle.
Ignore the circle.
Or the curved rectangle, what it, tell me like a
Really,
circle.
really the curved rectangle.
The racetrack.
Indeed so.
Other questions? Well, since we have just done a quadratic here, why don't we do another problem with a quadratic?
Indeed, so.
Actually, we'll start out with one without a quadratic, and, well, for one which we don't need to use the quadratic formula, and then we'll morph that into one where we do use the quadratic formula. Because this is a shift in topics.
Are we on to chapter 8?
No, we're gonna do